Welcome to this webinar where we are going to talk about an emerging topic in software development, microservices. Let me just to introduce ourselves. My name is Alessandro. I am a software engineer and technical advisor at Elastico and one of the organizers of Trentino Cloud Computing Meetup. With me, there is also Thomas Aliaga, software developer at Martel Innovate. Hi, Thomas.
Hi, Ale. Hi, everyone. This is Thomas.
Today, the webinar agenda will begin with an introduction to microservices, including key benefits and main challenges. After that, Thomas will show us a demo application for that. Actually, microservices is a hot topic in this moment, but also not too much explained. So we took the decision to organize this session. A lot of ideas behind microservices are not new. Splitting a monolithic application, integration with the legacy system, scale an application, and so on. So we can try to remember again which have been the steps before now. Around 19s, before service-oriented architecture, we had tight coupling applications where one change had an impact on the whole system. Around 2000s, moved toward the service-oriented architecture, or also SOA, as a style of software design where services are connected to another one through a communication protocol over network. In this case, we have loose coupling applications, different teams. We can have different teams for separate business areas. We have communication protocols. Say that we are here. So we have totally decoupled components where each one provides a solution for a specific business goal. Sometimes we talk also about bounded context. Having an independent component, also the impact of a problem or a change is limited, or at least can be mitigated. Have a look of this picture. This picture has been taken from Martin Fuller's blog. Martin Fuller is one of microservices father. We can see on left a monolithic application. And we can see it as built as a single unit. Applications are often built, in this case, in three main layers. We can have a user interface layer, a business logic or middleware, and data layer, where the server-side application is a monolith. So we can see it as a single big component that contains all. Any changes to the system involve building and deploying a new version of the server-side application. Furthermore, if we want to scale our application, it requires scaling of the entire application. In this case, we talk also about, we can also talk about vertical scaling. So I have just a solution in this case. We can, if I want to have more resources, I can also assign more RAM, or more storage, more CPUs. Say that we can also see on the right side, say that we can tackle the problem, building application as a set of services, where each of them service can be independently deployable and scalable. It is independent, can be seen as an independent component unit. Each service also provides a well-defined scope boundary. In this case, we talk about in this case, we can also talk about horizontal scaling. When I want to scale my application, I can scale just that service that is needed. So in this case, we can also talk about horizontal scaling. So I can add more instances for those services which need more resources. We can consider physical nodes as well as virtual nodes as a virtual machine or containers. In this case, we can we can deploy our service into a container, so or a virtual machine, and so far and so forth. So this is a small definition of microservices. I have put in this definition all the main the most important part of microservices. So microservices are small autonomous services which communicate by well-defined APIs, and each service implements a specific business goal. Now, from a design point of view, one of the important concepts is the single responsibility principle. Ideally, each service should have only a small set of responsibilities. Robert Martin, it is a very famous software architect, talks about designing classes using the single responsibility principle. It defines a responsibility of a class as a reason to change, where software module should have responsibility about a single functionality provided by the application. Robert Martin expresses the principle as a class should have only one reason to change. Related to this, there is also the concept of size. How should be small our services? A very poor metric could be line of codes. Sometimes we can read on blogs, on documentation or books that more or less a service should be developed in 100, 1000 lines of code. But a better approach is consider the business context and see a microservices as a process that can be finished, completed consecutively without interruptions or the use of other services. Which are the trade-off using a microservice approach? For sure, microservices provides benefit as a modular structure. We can have an independent deployment. So if I want to deploy just a single service, I don't need to deploy all the whole application, but just that service. We can also have technology diversity. So we can mix multiple languages. We can mix development frameworks. We can have also different data storage technologies. But these benefits have a cost. Which are the costs? The main challenges. The first one is that we are working with the distributed system, and the distributed system are harder to program. We can have also, since we have calls over the network, they can be also slow, or we can have some troubles with the network, so we can also consider this. We have the eventual consistencies. Maintaining strong consistencies is extremely difficult for a distributed system, which means that everyone has to manage eventual consistency. We keep in mind the CAP theorem. C for consistency, availability, partition tolerance. And we know that it's impossible for a distributed system to guarantee simultaneously all of them concepts. We have also more complexity. It's much complexity complex to manage our system. So we have operational complexity. We need a mature operations team. We should also consider that the infrastructure that is behind microservices application is a distributed system. So it's more difficult to manage that. Now, after this introduction on the basic concepts, it's difficult to talk about microservices in 10 minutes. We would like to show an example, a practical example of an application based on microservices. So now I let Thomas also speak, and just a moment. So Thomas, if you want, you can switch to presenter and show us the demo.
Okay. So hopefully you can see my screen now. Can you see the screen? All right, cool. So yes, exactly. As I was saying, thanks, Ale. I'll try to exemplify the ideas that he has just mentioned about microservices, launching a particular application, which is composed of different services. A really interesting application to use if you're learning, if you're new to this concept. The code of the application can be found in GitHub under this URL. I'm gonna use this example also with Docker to run it here in my machine. And so for those of you who are new to Docker, worry not, because I will be explicit in every step that I will be taking, so that you can grasp a little bit better the Docker ideas. I will be also using two tools which are developed by a firm called Weaveworks, and they're very useful for taking statistics and monitoring your containers or microservices as in general. So just before I do that, just for you to have a brief overview of the architecture of this application, as you can see from this image, it's composed of different processes, different services, as you can see each of these blobs here, and they have been developed in different languages, which is one of the characteristics of microservices as that have been mentioned. For instance, we have some in Node, some with Golang, and another set completely in Java Spring framework, for instance. And we have 4 networks, external net being the one that connects to the internet and making the interface for the front end. And this application is sock shops, so people can just log in and buy socks. This is a kind of a dumb example, but not so dummy, complex enough to have a good understanding of the concepts. So let's head to the command line. I'm not forgetting. Well, we have some databases as well, as you will see. So I hope I just took the license to make the font a little bit bigger. Can you confirm if you see a good size? If not, just let me know in the chat. I will try to make it bigger. Great. So what we have here in this, I have already I have the code in my machine. We're standing in front of the Docker Compose file, and I'm going to briefly show it to you. It's a feature of this of Docker that lets you, in a declarative way, say how your application is going to be composed into different services. So as you can see, we have from a front-end service, we have the specification of where the code is. That's the image. So this is the name of the Docker image that can be downloaded in your machine to out of which you will be instantiating containers. Okay, so that's the image. And for each service, you declare things like the host name, DNS properties. In this case, I'm going to run everything locally just to ease the example. But as you can see here, there's a long list of different services. We have also some database defined. For instance, here we have a Mongo for the shopping cart element. And so the different sides of the different parts of this online shop is divided into different services. Isolated environments developed in different languages, working all together. And at the end, we have the 4 networks that were mentioned in the diagram. So that's pretty much in the Docker Compose file. And okay, before running, I'm gonna start the service of the wave tooling so that we can have a better look at the whole thing afterwards. And with Docker Compose, when we have everything defined, it's just a matter of saying Docker Compose up. And I'm going to run the containers in detach mode, so I don't want to bloat my standard output. So as you can see here, the Docker has just created the networks, and it's creating each of the containers. These are the names. If you're for the first time running this thing, you probably would need first to fetch the Docker images from Docker Hub. So I mean, it's getting the source code of each of the services into the host, into the machine that's going to be running the containers. And since I did it before, as you can see, I have already pre-downloaded all the images. But okay, in any case, just running a Docker PS just to show the containers which are running. Hopefully this is not interfering to you. I'm just gonna make it a little bit smaller. So we have our application according to the status already running. So just have a look at it, just for you to. I'm in the local host, and there we go. We have the user interface where you can log in just for the sake of having some data. So probably, as you can see, it launched relatively fast. The fact that each service is in a container, it makes it a much more lightweight way to deploy a service in comparison with which would have been, for instance, a virtual machine or something like that. Let's say I buy one of these, and let's go to checkout. All right, as the order is already placed. So just for you, let me show you. So the good thing that is, as I mentioned before, you wouldn't be running usually in practice all your containers on the same host. That's the main advantage of microservices, that you can pretty much deploy different services and different places according to demand or things like that. And Docker lets you, for instance, do something like, let's see that. So I'm gonna do this. I'm gonna see this order thing. Just remember, so I can get output of the containers, of each of the containers. So for instance, let's say I want logs of the MongoDB of the orders database, and you can see here that you can see here the order I've just entered in the system, and you can do things like that, which show you this metrics of your containers in a very raw format, just in the command line. Or we can do something. We can use monitoring solutions, such as the one I was mentioning before. So this is this, and I'm going to close this one. So if we head to localhost at the 4040, it's probably going to take a little bit until it loads the information, but we can have a graphical interface for the metrics of our containers. And I'm not going to get into all the details of this tool, but just to show you that, for instance, here's the order part of our application, which is basically a Golang web service servicing request and orders MongoDB, we have just seen plenty of details from the process running, the environmental variables of that particular micro world where the process is running, which has nothing to do with my local environment out of the Docker container. So let's make something. Let's do something. Let's break things a little bit. I'm going to stop the service that says, for instance, so what was the name again? I always forget. Let's say that for a reason, our orders microservice stops running. So I'm just going to say stop it. And let's say for, I don't know, a failure in the system or whatever. So probably it's going to take a while until this persists, but as you can see now, it's gone. And we no longer have a orders service. But the good thing, as Ali was mentioning about microservices, is just for the fact that one of my services is not running, it doesn't mean that my whole application is down. So in theory, I could still use the the rest of the application, and it should be running just fine. I could be able to go to the catalog, even though it has nothing to do with orders, and that's a really advantage of having your functionalities spread across totally isolated containers. Of course, if I wanted to use now the service and the orders function, which I believe it was somewhere here, my orders, I no longer see it because it was down. So that's a good example. It could have crashed actually, but it's not crashing. It's just not showing the information. So let's say that we reestablish the container of the service. So just start it again. And you can see now running, yes, up 30 seconds. So now that it's running, we should recognize it here. Here it is again. Probably it's going to take a while until it reconnects. It reloads properly, but at some point in the front end, we'll be able to see again the orders that we had. All the pannings. Okay, let's give it a while. In the meantime, I'll just show you. Oh, there's a link. Just as I was mentioning, this one here represents the front end, which is interacting with other microservices from the picture Ali showed with different muffins, and as you can see, one down doesn't imply that the whole system is down. So this is not willing to show me the. Okay, there we go. This is the order I placed before. So Docker is really a powerful tool for deploying. It's not the only, but they're one of the really powerful tools for deploying your applications. Let's see, just to show you something else before I hand over to Ali. I think this. I hope this you can even do something like you can let's say that we want to play with the Mongo. You have a team responsible for the users, which have nothing to do with the rest of the application. So, and you want to debug something in the database of the users. You could simply do so. Like say you Docker. Let's get into this run bash, and boom, we're within a container which is running Mongo. We have it just to show you that here in my computer I don't have Mongo. I'm within a container, and okay, and then you can play around with Mongo as you would do, and in a totally isolated environment. Which is pretty cool. Okay. So yeah, I encourage you to have a look at the application. Really interesting for learning purposes. Very is a very nice application. And I think hopefully that exemplifies a little bit the ideas of the microservices that Ali just shown. I'll hand it over to him now. But feel free to send your questions in the chat box. In the meantime, let's see. Ale. There you go.
Okay, thank you, Thomas. Thank you so much. I think that, yes, it's very interesting, this demo, because there are a lot of topics that we are mentioned in the first part. We have different technologies. We have a very complex application because there are a lot of interactions between the services. It is really a distributed application. We also probably you mentioned also a RabbitMQ for the message queue. So there are a lot of inputs in this demo. Very interesting also the use of Docker with inside this demo. So there are a lot of technologies, a lot of interesting technologies, and a lot of inputs. So just for closing the webinar, I would like to remember that on the next 17th December in Milan, both Elastico and Martel Innovate will organize a one-day workshop where we will present more deeply all these concepts. So we will talk about design patterns, in general about microservices, but also there is a section on Docker, and finally we will develop our first simple microservice using Java Spring.